Hello and welcome to my presentation on probability tree diagrams. Probability trees give you a diagram that show all the possible outcomes for one or more event occurring. It gives you nice paths to follow and students find them very easy to deal with. The key things to remember when drawing probability tree diagrams and doing any calculations for this is that all probabilities add up to 1. If you get an answer greater than 1, you're incorrect. The word and means multiply and the word or means add. Here is a very typical GCSE question. You've been asked to work out the probability that somebody who rolls the dice 2 times in a row will get 2 6s. The branches of the probability tree get broken up into the probability that he will roll a 6, which will be 1 and 6, and the probability that he does not roll a 6, which will be 5 and 6. On the second roll, he has the same outcomes. He can roll a 6 or not roll a 6. He can roll a 6 or not roll a 6. Once you have the probability tree diagram filled in, you then need to have a column beside it where you list the outcomes. This is where the key words come in. You can roll a 6 and a 6. That means that we have to multiply those probabilities together. I can roll a 6 and not roll a 6. That means I'm going to have to multiply those probabilities together. As you can see, the only outcome that allows me to have a 6 and a 6 is the top one. The things that you need to remember when getting students to complete a question like this is that they need to always follow the same pattern again and again. Draw and fill in the probability tree diagram. Write the list of all the outcomes and work out all the probabilities of each outcome occurring. This will leave the students in a strong position to move on and answer any questions that will occur after the tree diagram is filled in. This is an extension of the question that we've done before. For this question, you've been asked to calculate the probability that you will achieve a C on both spins. You've been asked to work out the probability that you get exactly 1 3 when you spin 2 times. The first thing that you need to do is fill in the probability tree and then work out the outcomes. Once again, I will tell you that it is really important that you encourage the students to do the same thing over and over again. You then need to work out all the probabilities of each event occurring. Once you have done this, you need to take a look at the outcomes and isolate the ones that tell you that you have only achieved 1 3 from your 2 spins. In this case, I could have achieved a 3 and not a 3, or I could have achieved not a 3 and a 3. This brings us back to the original rules where and is multiply and or is add. I have already worked out the probabilities of each of those outcomes and now I need to add them together. This gives me 6 over 16. In the GCSE, it is perfectly acceptable to leave your answer as 6 over 16. However, if the students cancel it down, that is absolutely fine too. The previous 2 examples show independent probabilities. This means that the first event does not have an effect on the second event. For example, if I roll a dice, there's a 1 in 6 chance that I can achieve a 6. If I roll it again, there is still a 1 in 6 chance that I can achieve a 6. However, in some cases, the first event can have an effect on the second event, and this is called dependent probability. Dependent probability usually involves something not being replaced. The GCSE questions can sometimes be unclear whether or not things have been replaced, and it is up to you to support the students in knowing if it has been replaced or if it has not been replaced. This is a huge barrier to learning at times, and students can really have issues dealing with whether it has been replaced or not. This is an example of a typical question that can be asked on the GCSE. The key word in this question that students need to look for is without replacement. This indicates to them that 1 was taken out and it was not put back. So the second section of the tree will have 1 less. Students can get confused when filling in these types of probability trees. They need to remember that if you have chosen a blue, then there is 1 less blue to pick from on the second branch. Once they have successfully filled in the probability tree, it's all the same again. Fill out the outcomes, work out each of the probabilities, and then select the ones that you need. In this case, you will need all the ones that give you the same colour. Once you have those probabilities worked out, you simply add them together. If you are going to simplify, don't simplify till the end. Probability can come up on both calculator and non-calculator questions. If students simplify during the question, then they will not be able to add them together at the end. This concludes my presentation on how to complete probability tree diagrams.